Assalamualaikum and a very good day, everyone. For today's session, I will discuss about two-way ANOVA. Okay, what is actually two-way ANOVA? Okay, the thing that differentiate two-way ANOVA and one-way ANOVA is the number of independent variables. Okay, so now for two-way ANOVA, you will have two independent variables, or we can say that you have two factors. Okay, so now, how do you differentiate between what we call it as independent variables and dependent variables? Okay, for independent variables, this is variables that you, as the experimenter, change or manipulate. Okay, change or manipulate to see uh, what happened. While for dependent, it is the variables that you observe. Okay. In every experiment, they will have these two type of variables. So you have to determine, okay, and you have to differentiate between what is independent and what is dependent variables. Okay. For two-way ANOVA, now let's say that you have two independent variables, okay, and you are interested to study about what happened, okay, what happened if you change these two factors towards, as examples here, if we use the node example is the plant growth, okay. So uh, we want to see, okay, whether these two independent variable will affect the rate of the plant growth. Okay, and it is actually uh, what is differentiate between before this. Now you have what we call it as interaction effects. Okay, of the two variable. It means that now for these two particular variables, let's say that we have this A and this B. So you have interaction effect between A times B. Okay, so uh, instead of individual effects on the rate of the growth, now you can see what happened if there is effects on interaction. This means that uh, now we have uh, interaction effect of the two variables that we can be tested. Okay. All right. So let's take a look at example 14. Okay. Now they use suppose a researcher wishes to test the effect of two different types of plant food and two different type of soil. Okay. Maybe this plant food we can also consider as fertilizer. Okay. So you have two different type. Okay. Uh, two uh, two fertilizer and two type of soil on the growth of certain plants. Okay, so this since that you will change these two factor, you will manipulate this to see what happened. We say that this is independent variables, and now you have to. So the design that involved in this particular study is two-way analysis of variance. Okay, but it's actually quite complicated to do. So what are we trying to expose to you is just a brief introduction. Okay, we will be more focused on the examples, okay, rather than to describe it uh, uh, thoroughly. So you don't have to worry, okay? So to conduct this experiment, the research teacher set up four groups of plant as shown in the figures one. Okay. So since that we have two type of soil and we have plant food A1 and A2. So basically, this is how you will see the group of your the treatment group for our two-way ANOVA analysis. All right. So for group one, we have plant food type 1, soil type 1. Group 2, plant food type 1, soil type 2. Group 3, plant food type 2, soil type 1. And group 4, plant food type 2, soil type 2. Okay, so this particular group is known as the treatment groups. Okay, and the plants are assigned to the group at random. Okay, so how uh, how do we make sure that we randomize our plants? Okay, let's say that you have eight, okay, eight plants. So for each of this plant, let's say oh sorry, okay, so you have eight plants. Let's say that uh okay, this is actually eight lah. Okay, so I assign the number 1, 2, 3, 4, 5, 6, 7, 8. Okay, and for this particular uh eight, okay, so 1, 2, 8 as examples. And what I do, I go for a uh randomized. Maybe I create a randomized sequence of numbers. Okay, you can use this. You can use website or make. There is actually many ways to generate random numbers. And for this particular sequence, let's say that I got this particular number. Uh, After I do randomization, let's see. Okay. So let's say this is the numbers. So what I do, okay, so this 6 and 4, I will assign group 1 as a group 1. This 2 and 1, I will assign as group 2. This 3 and 7, I will assign as group 3. And this 4, 5 and 8, I will assign as group 4. Okay, so depending on the numbers, okay, I will choose plant food type 1 and soil type 1. As example here, plant food 1, soil type 1. Okay, for group 2, plant food 2, soil type 2. And so on, 3, and this is PF4, ST4. So when we assign this particular randomized design, we can make sure that every plant have equal chances to be selected. Okay, so and for this particular design, we call it as 2 by 2 design because each variable consists of two levels. Okay, two levels means you have soil type 1 and 2, you have plant food A1 and A2. Okay, the two-way ANOVA enable the researcher to, okay, first, what you can get by performing two-way ANOVA, you can test the effect of the plant food and the soil type in a single experiment. It means that you can take a look at whether um, is there any uh, okay plant food toward uh, growth, okay, soil type toward growth, and you can test the effect of interaction. So means that you have plant food interaction, soil type toward growth. So this is the thing that you can analyze by performing two-way ANOVA. Okay, so that's why when you take a look at the null hypothesis, you will have several null hypotheses because of this particular uh, okay, this particular design. Okay, one for each independent variables and one for the interaction. Okay, so let's take a look at how you write the hypothesis. Okay, this is uh, the hypothesis, right? So we have interaction effects. Okay, independent variable effect for plant food. So means this is the first independent variable effects, and you have the second independent variable effects for soil. Okay, so for interaction effects, the null hypothesis is there is no interaction. Okay, whereby for the alternative hypothesis, there is an interaction. If while for independent variables, you will have um, your null hypothesis to write as there is no difference. Okay, between make sure you write the correct hypothesis. Yeah, it means that when we write the interaction effect, you have to mention between plant food type and soil type on triangle. So means that you have to mention both A and B towards growth, whereby for independent variables, you only mention individuals. Okay, so plant food using different food. Okay, so in this particular dependent variables, we measure the heights of plants. Okay, so this is how you write the null hypothesis. And to create a summary table for two-way ANOVA, now you have this particular design. Okay, so you have source of variation, A, B, and the interaction, and also the error. Okay, so this is the formulation. In my example previously, uh, we take a look at how many levels of each of your independent variables. Okay, so A is stand for, okay, so let's take a look at this. Okay, A is for number of level of factor A. Okay, for B, number of level of factor B, and number of subject in each group. Okay, so for this particular example, they use, okay, how many levels of plant food. Okay, so let's take a look at this example. So how many levels? So you have two, so means that A equals to 2. Okay, how many level for soil type? Okay, you have 1 2, so B is equals to 2. Okay, so so how about your N? Okay, so your N. Okay, so when you take a look at the um the description, okay, N is number of subject in each group. Okay, so let's say that for this particular example, I have 8 plants. Okay, and for each for these 8 plants, I assign 2 random plants for each of the group. Okay, so my N is actually equals to 2. So because in each group, there will be 2 plants, right? For these particular examples, A equals to 2, B equals to 2, N also equals to 2. And then you just transfer the formula into this summary table. Okay, 2 minus 1 equals to 1, 2 minus 1 equals to 1, okay, 1 times 1 equals to 1, okay, 2 times 2 minus, sorry, 2 times 2 times 1, okay, equals to 4, and then 2 times 2 times 2 minus 1 equals to 7. All right. So make sure that when you total this up, it will be the same as this particular value. And we also have sum of square formulation, but we will discuss more details in next examples. And then the mean square, you just divide the sum of square by each of degree of freedom. Okay, according to the source of variation. Okay, so that's why it's actually easy for you to set up the summary table first before you start calculating uh, the particular elements in the uh, two-way ANOVA analysis. All right. So you have mean square for A, mean square for B, okay, mean square for the interaction, and also mean square for error. And for this particular value of the test statistic, as we can see here, you have three actually. Okay, three actually, the F value, which is FA, FB, and the F interaction. But when you see but you have to understand that for each of these particular uh, F statistic, you must divide it with the MSE. Okay, so when we talking about what is assumption for the two-way ANOVA, so this is basically the assumption. Okay, before we proceed to do the analysis of two-way ANOVA, we have to make sure that the population from which the samples are drawn are approximately normal distributed. The population from which the samples are drawn have the same variances. The sample drawn from different population are random and independent, and the group must be equal in sample size. Okay, so if each group have two plants, we have to make sure that every group have two plants. Okay, it's not necessarily two, maybe you can have three, but make sure every group have the same number of samples. Okay, and this is basically different types of two-way ANOVA design. Okay, depending on how many levels uh, for your factor A and factor B. Okay, so as we can see here, for this particular design, you have three levels of factor A. Okay, you have three level of factor A and you have two level of factor B. So this is 3 times 2 design. Okay. This one variable B, 3 times variable B, you have three levels, and also variable A, you have three levels. So this is 3 by 3 design. And for the last design examples, we have 4 levels for variable A and 3 levels for variable B. So this is 4 times 3 design. And for each design, maybe you can have you can have examples. You can have this particular numbers of subject in each group. Okay, so this is how you see this two-way ANOVA design. Okay, I will continue explain about two-way ANOVA by using example 15. Okay, um, we will discuss this later. All right. Okay. Thank you for listening. Bye.